And this is a show I've been looking forward to for quite a while now. Exactly since, I guess, the day before New Year's when my station controller arrived in the mail. So we're happy to have you here, George, and looking forward to hearing about the station controller. Kjetil is just watching the stream, so we have other Kjetil down here, also known as Jürgen. And what you're seeing now is actually that our cast is kind of becoming a little bit more fluid than it has been. Walt has his own thing, so he's not going to be able to be on as much. Sean's been on, but Sean's got to rest his voice for 4 months, believe it or not. So Jürgen is also going to be semi-permanently on the show.
Thanks so much, folks. Yeah.
Yeah. You've been a good guest, so why not let you in a little bit more? But before we let George talk about the station controller, let's do the ham radio moment of the week. And let's start with you, George. What's your ham radio moment of the week?
Well, I think we're going to talk about it on the station. So I think 99% of my waking moments have been spent working on that project, either the hardware or the software. But aside from that, I've been sorting through my portable gear. We have Winter Field Day coming up in a week. And so we've got plans to do that as a club. So I need to get the equipment all dusted off and make sure everything's working in the radio trailer and the batteries are all charged up and ready for that.
That is always a challenge. And I actually saw that Winter Field Day is a worldwide event. So I'm not sure how popular it's going to be here, though, but I might give it a go.
Is Winter Field Day in January? Is a global event?
It is. It's the 25th of Saturday, the 25th of January through Sunday.
But that's summer in Australia.
Well, everything's strange in the upside down.
Yeah.
Somehow I figured you'd come up with a comment like that, Bob.
Yeah. It's the way my brain doesn't work. So yeah.
But then again, since you're going to talk about your ham radio moment of the week, though, George, perhaps we should give you a little bit more time after we've done the rounds here, and you can tell us all about the station controller and why it's so great. And I can tell you it's great because I've been playing around with it for about a month now. Jürgen, what's your ham radio moment of the week?
Yeah, as I promised to Kjetil, this will be a short presentation from my side. There was not much. We started a ham radio course yesterday, so hopefully we will have 6 more ham club members soon. And overall, the week was very busy for me at work, so that was it.
Yeah, and I think that sounds like my ham radio moment of the week last week, actually. And that happens to all of us at some point.
Yeah. Since a software company from, I don't want to talk about this, let's say from the USA, changed something in the cloud service. I had a very busy week, let's say.
We just call that the unmentionable.
Yeah, that's right.
So, Tobias, what's your ham radio moment of the week? And before you start going, congratulations, Jeff, and welcome as a member of the European Ham Radio Show. Thank you. It's greatly appreciated. Sorry, Tobias.
Yeah, as you can see on my desk, things got out of control as usual. That is when you start thinking, hey, I need to order a few capacitors from Mauser or from wherever it's a preferred supplier, and then you think, oh my god, the shipping cost is so high, so you order a few extra, and then it looks like this, and then you have to find space and label them and put them away. And well, basically I had a go at my never-ending Kenwood refurbishment. So the status of last week or of Tuesday was, I managed to recap the broken one, which is on the left side. As you can see, the display is not working there, but that is completely recapped with new capacitors. So apart from the display, it's in good shape. And the other one was waiting for new electrolytic capacitors, and this is what I did today. And here you can see I got the old ones out and the new ones in, and it still seems to work. So that is more or less my ham radio highlight of the week. And I have a video coming out probably tomorrow around 6 p.m. European Standard Time. Yeah, so you can watch that, and it's basically a time lapse how I completely take it apart, how I desolder all the old capacitors, how I put the new ones in. So if you enjoy these kinds of things, you can watch that, and you get my live commentary of what went wrong and what problems I had and how I did it.
I'm so impressed, Tobias, that you actually take time to do this and actually do these kind of things. But I got to follow up on Bob's question from last week, since you ordered new capacitors and everything. Which radio is more expensive, the old Kenwood or the new Kenwood D75?
I think the new Ken was still more expensive, right? Yeah, I'm pretty sure. Yeah.
Even if you factor in time spent on this.
Well, it's my spare time, and I do it for fun. Yeah, so you can't count that time. Yeah, I mean some people find it completely annoying, soldering, and I find it really relaxing. It's like you go in like a Zen state, and you can really switch off and just get on with it. So I find that actually quite nice, a nice job to do.
Tobias, if you're feeling stressed out at some point later on, I have a TS2000 that could use a recapping, so I can send you that so you can relax.
Or your QMX Plus needs building, right?
and maybe you should start a new business.
And how are you with fixing mechanical issues on the tuner of an old Kenwood TS440?
Not very good, I guess.
No.
I mean, my mechanical skills are terrible. Well, or maybe in my head they are terrible, but that was mostly because when I grew up as a kid, I really had no proper tools at all to like simply drill a hole in a case straight and without completely messing it up. That was something that I could never do, right? So I'm thinking I should get one of these clockwork maker bench drills, where everything is properly mounted and solid.
Get a CNC machine. Get a CNC machine.
Yeah, or that as well, right? And a forge.
Renee's working on an old IC2E, and that is also you've done that, Tobias, haven't you?
I've done that, yeah.
Yep. I gave mine away.
If I made a video for that, I think I just posted on. I don't know if it was if I was already on Blue Sky at that point in time, but if it's an authentic IC2E, then it's easy because I think they have a connector how these two PCBs are connected. But I had some kind of clone version where they cut the connector, and there were a lot of wires crisscrossing from the one PCB to the other PCB in various different colors, and just getting those out and back in again, that was a bit of a nightmare.
I would imagine, but
so the capacitor itself, getting them out and replacing, that's the easy bit. But for the IC2E, with all the wires that are hanging out of that single layer PCB, that was a bit tricky.
Yeah, I ended up just throwing mine away. That was just so much. I'm not patient like you are, Tobias.
Very few
but
people.
I think
like
if
Tobias
it's already broken, right? So whatever I do, at the end, either I have a working radio or I can give it to the recycling, right? So.
And Ravi Newfarm, congratulations on becoming a member. Seems like we're gaining some traction here. But I am impressed, Tobias, and I'm looking forward to seeing your video. I haven't really prioritized YouTube this weekend, so
nobody's prioritizing YouTube in January.
It's January on YouTube.
The videos are there, and eventually people will catch up, I hope.
Yeah. Let's see, Bob, what's your ham radio moment of the week?
I have a few things, so I'll try and work through them quick. I started last week with doing things that I have no business doing and no knowledge of doing, so I continued that trend. So this week I've been doing LaTeX, which is a typesetting language. which it's a textual language, conceptually like HTML maybe, but you use that to create beautiful documents. So I needed to create some slides, and I think I would rather have all my teeth pulled than using PowerPoint. So I decided to learn LaTeX, and that's been fun. We'll see if anything nice comes of it, but looking good so far. And talking about the Python thing, this is I talked quickly about that battery test software that I created for the electronic load. I've been able to do some more tests. So I think I showed this last time. This is the battery that AliExpress claimed was 3.5 amp. No, this is my test battery. That's true. It's my test battery that when I bought it, it was claimed to be 2.5 amp hours. So I tested it at 3.5 amps, which is about 1.25, 1.3 Z. And it didn't deliver what it should. And I think you suggested, Tobias, that trying to discharge is at a lower current. So, of course, I had to do that. And lo and behold, 2.77 amp hours when you discharge it at just 0.26, so 0.1 C. That was cool to see. And, of course, then this was the abysmal result of the batteries I got from AliExpress. Basically about 1/3 of the stated capacity, but that was discharging at the claimed 1C. So I tried the same thing there and discharged with a lot less current and pretty much just as bad. So still 1.5 amp hours in these batteries. They can be used for some things as long as they don't catch fire. They can be used for something, but sure, absolutely not the capacity that was stated on the website. So beware if you buy batteries from
don't buy
AliExpress.
batteries from AliExpress. This is what we learned, right?
I wouldn't say that, but be prepared to test them and dispute the charges if you get crap like this. I would recommend. That was the technical stuff, and I've been on summits. I've been on 3 summits today. So, yeah, can we embiggen that picture because it really deserves to be embiggened?
No, I don't think we can. It's something about the format of your window, though. If you make your window that you're sharing wider, that should
like
help.
so.
Like so.
Nice. Yeah. This is the first summit of the day. I drove up there yesterday evening. I slept in the car to get an early start. So this is at 9 o'clock in the morning. I'm on the way up to the summit, and I've been sort of disillusioned by winter and all that because it's snow everywhere. It's cold. You're freezing. But so you sort of forget why you like going up mountains in the wintertime. But then this happens. This
That's
just
great.
fantastically fabulous view, and so I remember.
What planet were you on that has 2 suns?
That's an artifact of my camera, sadly. That's the cameras in the iPhone 15 Pro, I think, creates that artifact. It moves around, so
That's on
I'm pretty
Tatooine.
sure it's not the sun.
That's what I was wondering.
Yeah. So, and of course, then, there was first activation of that summit. This is at about 9:30 in the morning, I think. I wrapped up the first activation. This is the second summit. A lot less snow, but a bit harder work to get up there. And, still beautiful with the sun and all. And finally, this one, which is, to be honest, that was a drive up. If I moved about half a meter back from where I'm sitting there, I could rest my back on the car. But you're not allowed to rest anything on the car when you do summits on the air, so I didn't. But, 2 summits on a drive up. I think that's pretty all right. That should put me at, I think, 930 sort of points. So I'm 70 short of the mountain goal.
So at this point, this is just a numbers game for you then, Bob?
No. Or I don't know. No. This gives me the excuse to go on expeditions to places with nicer mountains and more points. So, yeah.
So are you running just the 5 watts off the internal battery? With the
No.
charge?
I'm running that on the. If you see that on the side there, you see that's a USB power bank.
Yeah, but it's probably delivering. Oh, is it going into the 2.5 millimeter jack or the USB? I can't tell.
That's a USB power bank with what's called a trigger cable, which turns that into or instructs the power bank to deliver 12 volts.
Oh, okay.
And, that goes into the side. So that's full 10 watts.
Great.
That is so nice. That's what's called, amazingly enough, a 10,000 milliamp hour power bank. And that thing, it's small if it's in the palm of your hand. And that thing, it will... I did, when I was in Germany, I did 5 activations some of the days, and still that was above 50% when I was done for the day. So it's all you need. I've been carrying around way too bigger batteries for this kit. So power bank like that and trigger cable is all you need for the 10 watt 705. That was a long detour onto to my week, but
Yep.
I guess I can ask you.
Mine's going to
How's
be
your
long as
radio
well.
week
So,
been, Morten?
First of all, let's see if we can get your summit picture away from the screen here. You managed to do that. First of all, Prep Ham Paul gave away 5 memberships, so we're obviously on a roll tonight because more people have become members in the first 10 minutes of the show than ever before. And the people that got memberships are Cooley, KA9, and I don't have my reading glasses, QZG, I think. Jürgen became a member. René Andersen, Chris
Thanks so
Bricker,
much.
Wade, VA3, NCA. And those were the 5 guys that became members. So thank you so much, Paul. And now to my ham radio moment of the week. As a couple of you guys probably know, I've been to the land of bagpipes, haggis, and kilt this weekend.
And good whiskey.
Yeah, my wife calls it a romantic getaway. I like to call it a little bit of a de-expedition. So why not meet up with some Scots while you're in Scotland? So I was supposed to meet up with Charlotte from the Discord here. She couldn't make it, unfortunately, but I met Colin, MM0OPX, the guy that the Smoking Ape at one point called the Antenna King of Scotland. And we activated, let's see, what's that park called? Edinburgh Old and New Town UNESCO World Heritage Site, GB3071. So we met up there.
That name, doesn't it?
Yeah, we met up there, went up to a high point in Edinburgh at Calton Hill, and I figured I'd call in my power bank. So I brought my power bank. The thing is, though, I've misplaced my trigger cable somewhere. At least it wasn't in the bag that I brought. So I went through a lot of work getting the correct power bank, the correct trigger cable, which you made for me, Bob, and everything to bring to Scotland. And at this point, I don't know where that trigger cable I was supposed to bring is.
I'll make you a new one.
Yeah. So I'll probably find it. I'll find it, though.
I'll make one for you as well, Judge.
No, I meant 2 for him.
Yeah, he made 2 for me, but the other one was at home, and probably the first one as well.
Yeah.
So up there, he had power, and he brought a little bit of a contraption of an antenna. And somewhere during the activation there, I said that, well, I need to copy your design here, Colin, because this is genius. And at the end of the activation, it turned out that Colin had actually made this antenna for me. And I think this is what he calls the adjusty wave. So it's a 49-to-1 here. This is a QRP balun. And then on this reel here, I think this is a fly fishing reel. You have some rope and some steel wire. You plug the unan into here. Then you pull all of this up to the top of your mast into a pulley and attach the end to this. And then you can just wind it back and forth to actually make it resonant on every band. And I've seen Colin use this before, and it has always looked cumbersome to me. But when I saw him using it, it was the easiest system in the world to deploy and use. So there's going to be a video on this, and this is the video I really want to get out first, but I do have a couple of videos that I have some obligations that I need to get out before this one. But there is a video coming on this system because it's pure genius. I was actually hoping he brought his Scott hex. I don't know if you guys have seen his video where he builds a hex beam for 200 pounds.
Nope.
Nope.
Yep.
And he's got Yeah, he's got a complete bill of materials and everything you need to order from Amazon in order to build that hex beam. But this is pure genius, the system here. So we went ahead, made that activation, and Colin showed me where they filmed Train Spotting, which is one of my favorite movies. And that's my ham radio moment of the week. And then you talked about elevation meters and walk-in. When you look at a map of Edinburgh, it seems flat. I can tell you,
But
it's
it
not.
isn't.
It's not anything close to being flat. So, and there are stairs everywhere, but they on Google Street View, they look nice and short. They're not.
So, but you looked at the map, and
No,
you were surprised that it wasn't as flat as the map.
I used Street View as well, but you don't get an indication on Google Street View exactly how steep it is.
All right.
And how many different directions it's steep. It's steep no matter where you go, and it's usually uphill.
Okay, that's Edinburgh. Usually uphill. I see
ways.
we have our last week's guest, Lima Bravo 8, into Julia in the comments, and
we gotta give him. Yeah,
congratulate him on making Hackaday today. That was his. I don't know if you've seen the video, George. You need to get him on your podcast. He created the TEHRS compatible tuner thing.
Oh, I saw. I did see that. I did see that video. Yeah, very clever.
Yeah, that's fantastic and really, really beautiful handiwork on that tuner thing. He's in the comment.
Yep.
Congratulations on making Hackaday. That's pretty big.
That is
That's awesome,
one of the most amazing things I've seen, actually. And I haven't seen it live yet, but really good work doing that. But I guess
short comment for Ravi in the chat. This is my IC2E. Maybe you can quickly embiggen it, and then everybody understands what I meant with a mess of wires.
I'm just going to find the right button here.
Yeah. So as you can see, replacing capacitors easy. Getting access to the capacitors, especially in the top middle section, not so easy. Okay, that's everything I wanted to share.
Yeah,
yeah, that is actually quite a challenge. But George, the station controller and the subject on what's on your workbench on your podcast for several months now. We want you to talk about it. Simply.
Sure. Where do we start? Should we just maybe start with describing what it is, what problems it's solving, and then we can kind of go from there?
I think that's a good way of starting.
Okay, so let's define what a station controller is. So we'll just make up the definition here. So if you break it down, station controller, two parts, right? Station, what's a station? So the primary application started out with remote control of your HF or VHF station. But as it turns out, station could be other things too. It could just be automation of the station that you're sitting in, that you're controlling. It could be a repeater system up on a mountaintop somewhere. And the whole notion of the control aspect is to be able to monitor and control that equipment remotely. And so take, for example, a remote HF station, Morten, like what you're setting up there. So in the remote HF station operating world these days, I mean, if you go back, let's take a step back in time, 20 years ago, people were doing remote station operation, but they had to create their whole environment on their own. So it was really a massive DIY project. And the radios really weren't designed to be remoted per se. So you had to figure out, how do I manipulate the radio? How do I pipe the audio? How do I turn things on and off and all that? And figure it all out yourself. In the last 10 years or so, you've started to see the major manufacturers architecting their radios to make them more easily remotable. So the most famous example, I would say, is Flex Radio. From the beginning, their radios were pretty much remotable. Certainly the 6000 series is inherently remotable, meaning that the radio and the control surface, the knobs and buttons or the software, are really independent. And so you can put the radio anywhere and the control could be anywhere in the world. And as a manufacturer, they give you the solution for how to remotely control the radio. So you can operate the radio as if you're sitting at the radio. It really doesn't matter to the radio. And they also solve the problem of transporting audio back and forth. between the user and the radio, regardless of where you are. So whether it's Elecraft or ICOM or Flex or whoever, they're all moving in that direction to make the radio more remotable, at least the higher end versions of their radios. So the remoting the radio is kind of a solved problem, at least if you're going to go out and buy a pretty recent vintage radio. But to have a fully remote station, there's a bunch of other stuff you have to have or would like to have. And you can imagine some very basic things like you need to have a way to turn the equipment on and off. I don't mean just because it's a safety or a power consumption thing, but like in the US, it's legally required. You have to have positive control on the transmitter, which means that if something goes haywire and the transmitter is transmitting out of your control, you have to have a way to shut it off. Yep. And they don't care how you do it, but you just have to have a way to do it. So you need to have a way to turn the gear on and off, to turn the transmitter on and off. There's a lot of vital signs of the radio station you'd like to monitor. So for example, you'd like to know what's the power supply voltage or the battery system voltage. You'd like to know if you have AC power at the site. You'd like to know if the temperature of the transmitter is high. You want to know what the forward and reflected RF power is going to the antenna. And the reason is that all of those things are leading indicators of potential problems at the station. Or if the station's not working, you need to be able to diagnose it remotely. And you can't necessarily just like drive to the remote site, which could be hours away or maybe further. So you need a way to measure all those vital signs. And then there's some things you want to be able to control too. Like, for example, you might have multiple antennas. So you might be selecting multiple antennas to your radio, or in the case of automating your shack, you might have multiple radios and a single antenna, and you want to be able to conveniently switch between the different radios at the push of a button. So, so essentially the station controller serves that purpose. It lets you monitor and control all kinds of stuff around the radio gear. So the short story is, if you were gonna make a remote station today, you can just go write a check and buy a radio that does it off the shelf, like a Flex radio, or and now more and more the Elecrafts and so forth. But the rest of it, there's really not an out-of-the-box solution. And so my goal was to make a very easy to deploy out-of-the-box control system for everything else that sits around the radio.
And from what I can see, you've managed to do that pretty well. I got to say, though, I am, if you don't know, I'm in the beta test group for this station controller. And it's a little bit sad, George, because I don't really have anything to report on the system. It's simply, I have no major faults that I've found on it. And the minor faults are stuff that has been my own fault and not the product's fault. So,
I do know one major fault you actually identified that has since been solved, and that is that the temperatures are all reported in Fahrenheit, which is apparently a system that you're not familiar with. So the latest version of firmware will let you switch between either reporting in centigrade or Fahrenheit.
Yeah, that is really nice, because I posted a picture, I think, on Facebook, and I just got to share this though before you go on. And as you can see here, my temperature is 73.85 degrees, and someone commented if that temperature probe was in my cup of coffee.
Yeah, it should probably put the units of measure on there on the display. But the new version, there's just a software switch you make, and then it reports it in C, not F.
Yep, that is really nice. I'm looking forward to that. But hardware-wise, though, George, I know there was a couple of software issues that kind of were solved before I got my station controller. But since I got it three and a half weeks ago, it's just been working flawlessly.
That's great. So the best kind of feedback is nothing to report. As opposed to here's all the problems.
Yeah, but
so,
it's boring though when you're a beta tester and there's not really anything to find.
Actually, that's super valuable. I mean, the reason that we did the beta is because we wanted to provide the system to a handful of people who would deploy it, and this is the kind of feedback we really wanted to see. So if the feedback is, it's all great, it does what it's supposed to do, that's fantastic, right? Finding bugs is even more useful, but just the fact that it works is reassurance that we made a lot of the right decisions. So it had been I've been working on it for a long time. So my goal was for the beta to be as functional and useful as possible, as close to a final product as possible, knowing that there would undoubtedly be things that people would find. So far, there haven't been any bugs, but there's been probably half a dozen suggestions for additional features or stuff like that. So that's been good. And there's some new things that have gone into the firmware since the version that I sent you. So we'll be upgrading that at some point to the latest version of all the firmware.
Nice. And perhaps we should take a little bit of a step back for the viewers, though. Hardware wise, what is the magic that you have designed here, George?
So back to the goal. The goal was to make a complete system that's really plug and play. So what I didn't want to do is provide something and have the user go, spend a week learning some complicated programming language or hardware setup. I wanted it to be an out-of-the-box, easy snap, plug and play kind of thing. And yet the architecture is also designed to be extensible. So if you wanted to customize things, integrate it with other stuff you're doing and so forth, you can do that as well. So we can kind of get to how you do that. But let's start with the hardware. So the hardware consists of modules. A module is a circuit board, and all the circuit boards are mounted to a base plate, partly for protection and also for mounting purposes. And in the first batch of boards, there's 4 different modules, and you can think about it architecturally. The heart of the system is a computer that's running Node-RED as the control surface, the dashboard, all the virtual buttons and knobs and gauges and stuff. So a computer running Node-RED, and then it talks to one or more of the control modules, and there's 3 different control modules that do different things. And architecturally, over time, I can extend the platform with more and more modules. So I have other, I've got 4 or 5 more ideas in mind of things to probably do. But I wanted to put something out that was really the essence of what I thought most station controllers need to have. So first module is a Raspberry Pi host adapter. You can take any PC and put the Node-RED software on it and plug in a dongle and connect it to the modules. And so you don't need to buy anything special to actually run Node-RED. However, if you just want something off the shelf that plugs and plays, you don't need to install and configure everything, then the Raspberry Pi host adapter lets you take a Raspberry Pi module and plug it in. And then it provides some other nice features on the board. So it's got a built-in 12-volt power supply. So one of the goals is everything runs off of 12 volts. So you don't want to have like a 120 or 240 volt wall wart running your Raspberry Pi. So there's a power supply built into the board. You can plug in either a power pole or a barrel connector. This is the power supply for the Raspberry Pi. And then the Raspberry Pi talks to all the control modules through these jacks over here. So obviously this is Ethernet to your network. This serves up the web page, which is written in Node-RED, and of course you get the source for the Node-RED dashboard. And if you want to use just the stock image, that's fine. Or if you want to modify it, you can. This is a Raspberry Pi 3. I've tested it with a 3 and a 5, and of course it works with I'm sure with a 4, but it does work with a 5. The only downside to the 5 is that it draws more current in general than the 3. So the 3 is kind of the sweet spot. It's also cheap. So the Raspberry Pi 3s are about $35, $40. And it's quite sufficient to run this application, but a 5 would work fine. The interconnection between all the modules is a connection scheme that's unique to this system that I call a device control network. So the device control network provides the data and power through these RJ45 jacks. So these are not Ethernet, no Ethernet at this point. So if you're going to, let's say, plug into another module like this GPIO module, all you need to do is plug a piece of Cat5 cable in this jack and in one of these jacks, and that's it. It's hooked up. That Cat5 cable provides power and data. So 2 of the pins are data, and 2 of the pins are ground, and 2 of the pins are 12 volts. The nice thing about that is, let's say you plug power into your Raspberry Pi host adapter. That 12 volts comes out these jacks here, go to the modules and they'll power the modules. So each module does not need its own power. It's powered off the network. So there's 3 modules. There's a general purpose I/O module, which, as the name implies, has a lot of sort of universally usable interfaces. There's a coaxial relay module, and there's a wattmeter module. So the GPIO module has got 18 I/O channels. Along the bottom here on these terminal blocks, there's 4 DC voltmeters, 0 to 50 volts. And this uses a 16-bit analog to digital converter, so it's pretty accurate. There's 4 relays that are built into the board you can see here. So those are small signal SPST dry contacts. There's also 4 open collector outputs to drive a larger relay. Let's say like a big relay it's going to turn your power on and off. There's 4 digital inputs for switch closure, security, door switches, whatever. There's 2 temperature probe jacks up at the top, and those are for digital temperature probes, so there's no calibration required. And then all the boards, all the modules have an LCD display, which is removable. You don't need to use it. So if you're going to put this at a place where you're going to want to glance at the display from time to time and see what the measurements are that it's making, you just leave the LCD on. If you're putting this in a closet somewhere and you don't want to, have the light or the current consumption from the meter, you can just unplug this and put it aside and just, run it without that. So that's the GPIO module. The next one is a coaxial relay module. This one doesn't have the connectors installed on it. So the coax relay module is 4 ports. There's a common port and then 4 selectable ports. And it's really intended for HF. So it's perfectly fine at HF and 6. It's actually not bad at 2 meters, although it's not designed for that. There you go. So you can see that it's got right angle B and C connectors coming off the bottom. So one of the highlights of the coaxial relay module is that it uses latching relays. So let's say you select antenna number 2 and you lose power. Antenna 2 is still connected. So whether you have power or not, you're always on whatever the last position was that you left the relay in. So that's very handy. So it's good for HF, good for 6, okay for 2, not very good for UHF, not designed for that. So,
yeah.
That's that. And by the way, some people are like, well, I don't have 4 antennas. I only have 1. Usually what you do for a remote station is at least have 1 antenna and 1 dummy load. Often you might have 2. Maybe you have a vertical and a wire, or a beam and a wire antenna, or maybe you have a 20-meter beam and a 40-meter inverted V. Well, that's 2 antennas plus a dummy load. That's 3. So you've got 4. When I first built this, my first application in my shack, I've got 1 antenna. So I would put my 1 antenna into the common, and then I'd have different radios, and I would select between different radios. And then the third module is the wattmeter module. Again, you can put the LCD display here, and it shows you the wattage. There's 2 ports on the wattmeter module. Each of these ports allows you to plug in a bidirectional directional coupler. So a directional coupler is an RF sampler that measures the wattage going forward and the wattage coming back from the antenna. So you can have 2 HF antennas, an HF and a VHF antenna. It depends on the coupler. The couplers we use are made by a company called WaveNode, and they make wattmeters. And we don't actually use their wattmeter console. We just use their sensors, and they just plug right in. And there's different modes of taking power measurement. You can take measurements constantly and stream it to the dashboard, or you can perform a test where it keys the transmitter, takes many samples, averages them, and returns a value to you. And there's different modes for different kinds of transmitters. So if you're operating a single sideband transmitter with a variable power output, there's one technique. If it's an FM repeater, there's a different technique that's built into the system. So the other thing that's nice about the system is that because of the nature of this device control network, you can multi-drop as many modules on that network as you like. I mean, realistically, no one's going to have probably more than a dozen. But I mean, a basic station is at least 1 module. Typical station, I think, is going to be 3. And a larger station is going to be more. So, for example, a friend of mine, Mike, VA3MW, has got a very nice remote station in Canada. And to do everything he wants to do, he's going to use 4 of these GPIO modules and 2 of the wattmeters and I think 3 coax switches. So that's a pretty big system.
And
But
that
architecturally, it'll handle it no problem.
that actually answers Jeff's question here. If you can add more antennas.
Sure.
And then-
I mean, what you think about the switches is a 1 to 4. So you could do whatever you want to do with a 1 to 4. So one thing that's come up actually is I have multiple radios and multiple antennas. How does that work? And the answer to that is if you have 2 of these, you just couple the commons together. And so you can have 4 radios going to 4 antennas, 1 pair at a time. And you can do that with 2 modules.
Excellent. And the designer of that beautiful TEHRS compatible coil, Øystein, asks, what is the brain of the modules? Is it an Arduino?
Good question. Yeah, the processor on the module is an ESP32S3.
Yeah, so a little bit more than an Arduino then, Øystein.
Well, what's an Arduino? So it's more than an AVR, 8-bit. So ESP32 is a 32-bit processor. It's the latest one. The S3 is the family of ESP32s that lets you have the most amount of flash and RAM. So that gives me a lot of headroom to add a lot of features.
Yeah, and these days it doesn't make. Sometimes it's harder to get the original AVRs than an ESP, right? That's even cheaper.
The crazy part is yes, although that's better now. The craziest part, Tobias, is that the ESP32 in many cases is cheaper. So I give you an example. I did some projects with at Mega 2560 or whatever. I forget the big one. Those parts are like $13, $14. The ESP32S3s in quantity is like $6. So,
exactly. Yeah. It's somehow really crazy.
Yeah.
And,
I think the AVR parts are now considered legacy parts, so that's the reason why they're expensive. They're dipping into legacy stock.
Yeah.
Exactly, and you get so much more megahertz and power and flash with less expense these days. So why not use a more modern device, right?
Yeah, that's right. One thing you do find, by the way, is you don't get that many pins. So you get all that good stuff, but you're very pin limited, surprisingly, on the ESP32s, because while they do bring a lot of pins to the surface of the module, a lot of those pins are reserved for things like memory and other stuff that's also on the module. So you can't always use all the I/O pins, and some of them have some funky behaviors. So coding for a AVR is really, really, really easy. Every library that's ever been made works on an AVR. All the pins are pretty simple. Life is good. But when you go to the ESP, then there's a lot of things that'll bite you in the butt. And they all did.
Yeah, but maybe that's why this I don't know, the programming suite, this Ice Cube has this nice generator where you can say, oh yeah, this is exactly the chip that I've chosen, and then they tell you what it can do, and then you basically have a big drop down list to say I want this pin to be a GPIO and that one to be a I2S, because if you do that all manually from the data sheet, you will spend a lot of time and get a lot of new gray hairs.
Yeah, and there's a lot of hidden things like if you didn't set this fuse right, and well, what's a fuse? So there's quite a learning curve. I mean, to do something simple, it's no problem, but when you start building a really big application, and the amount of firmware in one of these modules is really kind of big, and there's just a lot of stuff that I'm exercising, and there's a lot to learn. But anyway, but I'm kind of past that point.
We got a lot of questions coming in, George. Do you want to take
away.
them as they come in? Or
Sure. Yeah.
Yeah. First of all, Jeff is wondering if it's possible to write code that would prevent 2 radios from selecting the same antenna. And I guess the answer to that is yes.
Well, you don't have to write any code. I mean, it depends on what your configuration is. If you have one antenna relay board, by definition, only one port is active at a time. So the way the firmware works on this, there's the way they work on all the modules, the host computer that's serving the web page, which is typically a Raspberry Pi running Node-RED. By the way, you don't have to use Node-RED. You could write your own control panel in Python, or whatever, because I publish the commands for the modules. So all you need to do is send the proper commands into this port, and it'll do what you ask. So for the antenna module, there's a command called select. And if you say, I want to select port 1 or select port 2 or select port 3, etc., what it does is it disconnects all of the ports, which is probably only one that was previously connected. So disconnects all the ports, pauses for a programmable period of time, typically half a second, and then connects the port that you ask for. So the firmware, if you use the command select, the board will only let you have one thing connected at a time, or nothing. You can choose to disconnect all of them, but it's either everything disconnected or one at a time. You can't have two connected simultaneously.
Yep. Abe is wondering if you're using Wi-Fi or the Bluetooth part of the ESP.
No, I'm not. Actually, that's going to be a future enhancement. So one of the reasons to use the ESP32 S3s, the new family, they have Wi-Fi and Bluetooth built in, which is really great. So there's enough memory so you can have the stack and use those features. In the first delivery, the first version here, everything is either wired or wireless over my own interconnect scheme because it's completely controllable and predictable. When you start using Wi-Fi, there's some cool things about using Wi-Fi, but there's some downsides to that too. So eventually I'm going to release a version of the firmware that also supports Wi-Fi, but I didn't do that in the first go around here because setup is more complicated. By the way, take a step back. I found there's sort of two camps of users in general for most ham radio products. There's people that just want a thing. They want to take it out of a box. They want to plug it in and have it just work and not have to do anything to set anything up. There's another group of people who are very technically savvy, who are also interested and have the time to understand how something works and want to really dig into it and mess around with it. So I have to be able to support kind of both. And so a lot of the decisions were around making it a out of the box plug and play, and it just comes up and runs. But if you want to do other stuff with it, you can. So Wi-Fi is something that'll be added to that. One of the things that's very cool about the ESP32s that I really want to experiment with more is they have a proprietary feature called ESP Now. And ESP Now uses the Wi-Fi hardware and some of the lower levels of the Wi-Fi stack to do a device-to-device direct communications. So it's kind of like Zigbee. It's kind of like in what's typically called an 802.4.15 stack, like a home automation, industrial automation stack. So they have their own proprietary version of that running at 2 gigs, which would be fine if you want to talk between modules in a room, for example. And so I think I'm going to probably take advantage of that at some point.
I am going to just bring my own experiences with Zigbee and Z-Wave to the table here,
please,
George, because I have pretty much every light and some other home automation stuff wired up. It is not stable enough that I would use that on a station which I wasn't physically at.
Yeah,
to put it simply, because at some point that fails.
I have a question regarding that, because I would think maybe Zigbee would be more stable in the house where there was not a lot of 100-watt radios in the middle of it.
Well, so I can tell you, I've built a lot of other products before using radios from a company called Digi International. So Digi International is pretty famous for making these little modules that are about an inch square that are called XB modules, XBEE, and they come with a variety of radios on them. And so I did some systems with a lot of 2 gig radios that essentially it's like Zigbee, but it's their own meshing protocol. And in a lot of RF environments, like repeater sites and that sort of thing, they're super reliable. I think the problem with any of the consumer things like Zigbee, et cetera, is you have to pair the things up, and if the pairing falls apart, then there's failure modes you can get into that are no big deal for like your lights. But like you say, Morten, do you want to rely on it if you're 100 miles away and your station's in transmit and you got to shut it off? Not really.
I wouldn't do that because I got a light switch in my bedroom. If not every light turns off when I go to bed, I can actually get out of bed and turn it off manually. But if I'm on the other side of the world remoting my station, that's a whole different set of issues. Got another question here from Rasmus from Sweden here. How much port isolation is it between the ports and the coax relay?
That's a good question. I ran some sweeps on it, and I don't have the chart yet right in front of me, but it's across the whole HF and 6 meter band. It's between about 53 and 65 dB of isolation, which is I would say fine for most applications. More isolation would be better, but more isolation would also be more expensive. So I think for the typical station, this is more than sufficient. I could imagine making a better one, but it would be at a significantly higher cost. So, and that's something we might do eventually.
I think also you went into a lot more details on the second to last podcast. I seem to recall you rattling off all the numbers for port isolation in that podcast. So if you're really interested, you could check out that.
Yeah, if you don't get enough information from this show, you could always check out the Ham Radio Workbench, and you'll get some information about the station controller there as well.
Yeah. Yeah, the two specs we really looked at, it was most critical for the antenna switch is what's the insertion loss? So if I run a signal through this thing, how much am I going to lose? And the answer is less than 0.05 dB, so it's essentially nothing. And then the port isolation, which is the other critical thing. So 55 to 65-ish dB is really fine for a typical station kind of configuration.
Yeah. We're probably going to run a little bit longer today than usual. We've kind of prepared.
I was just going to laugh, like you didn't see that coming.
That usually happens when we have one of you guys from the Ham Radio Workbench on.
Totally coincidence.
How far away are you from release on the station controller, George?
Actually, pretty close. So the goal was to fan it out to betas first. We have now 11 beta sites, one in Norway that's working on it. So so far, all the feedback, like I said, there's been no problems. So the first thing you look for before you're ready to release is there any sort of fundamental flaw in the design? And I would say that we've run into absolutely nothing like that. There's been a whole bunch of minor enhancements. So like, for example, on the GPIO module, there's commands to turn the relay on, turn the relay off. Now there's commands to pulse the relay. There's programmable delays. There's triggers for thresholds on the voltmeter. I mean, so there's a bunch of features that were added that probably 90% of the people will never use, but somebody needed it, so we added it. So we're kind of holding back until the number of kind of obvious good idea feedback items kind of wind down to nothing. And I think we're getting there pretty quick. Probably the lion's share of work still to be done is not any more on the modules, these modules anyway. It's more on the Node-RED dashboard, and it's fully functional, but you can infinitely enhance that. But the nice thing about that is that's just downloadable off the web, and you can install that whenever. So it's nothing you have to ship anybody. So to answer your question, at this point, I'm planning to release it officially in February. So unless somebody finds some disastrous problem, but so far so good.
I did find one thing though, George, and I think I mentioned it, and that's I need to choke off the Ethernet cable or the cat cable between, or actually more precisely, going into the coax switch.
Mm-hmm.
But that's a minor issue. Most hams have chokes lying around pretty much everywhere.
Yeah. So far, by the way, everybody who's testing it, nobody's had to choke anything, which is really a relief, honestly. And everybody's station is going to be different. And so finding, like in your case, Morten, that you needed to choke something, I guess is not a surprise. But
that might as well be my station, because it's a heavy RF environment, and it's no station is the same.
Jeff has a good question here.
Yeah, go ahead.
Jeff has a good question here about the firmware updates. Will they be available through the dashboard?
That's a very good question. If it's possible, yes. But so far, I haven't figured out how to do that. But frankly, I haven't spent the time on that. So right now in the beta, there's no way for the beta users to reflash the firmware with updates. So my goal is to get the firmware to the point where it's done, and all the customization will be done in the dashboard. So there's always this architectural question of how much programmability do you want in the device versus in the main control thing, which is in this case Node-RED. The more stuff you put in the device to make it more programmable, the more it's a pain to bake stuff like that, and you could potentially bake in more instability in your code in the firmware because things get very complicated. So philosophically, you kind of want to keep the code in the devices to be as simple as you can get away with, and then put the customization in the dashboard where it belongs, because that's infinitely reprogrammable on the spot. So anybody can make a change at a moment's notice. And a new release of a dashboard, especially Node-RED, is nice because you can either take the whole dashboard and replace it, or you can just take a fragment and just instantiate it in your dashboard and update it, and you're done. No compiling, it just runs. And so updating stuff in Node-RED is much better than in the firmware. Now, having said all that, the ESP32's the Espressif does make a firmware flasher software available. When you've flashed the firmware, you have to have multiple binary files, and you have to go into the flasher and say, here's my 4 files, here's the address where each of those 4 files are loaded into in Flash, go. So it's not, anybody who's done any microcontroller stuff, no problem. But Joe Average Ham, who is not going to build a dipole, is not going to have a good time trying to figure out how to reflash the firmware. So I don't know, and it's really not so much us. It's like, well, what does the Espressif ecosystem support? So if there's a way to do over the air, i.e. remote over the network kind of updates, or through the Node-RED dashboard, if we can figure out how to do that, we definitely will do that. But at this point, that's not there.
Oh, you're using the C++ API for programming these. Yeah, I was under the impression there was some project for over-the-air updates for ESP32s.
It might be. It may also depend on which language you're using, because sometimes it's different between using MicroPython or C.
Yeah, absolutely. But that's why I asked about C, because I thought that was
maybe
specifically for C, but I could be misremembering.
Well, it's vendor specific, so it's not generic to being a C compiler. So, like I said, we haven't really dug into it deep enough. So my superficial looking at that was like, there's not an obvious easy way. So I've done a ton of projects with PIC microcontrollers in the past, and flashing the PIC was pretty easy because you plug in a programmer, you open a file, you hit the program button, and it squirts it into the part, and you're done. That's kind of what the Espressif tool does, but you have to squirt 4 files at specific addresses into it, so it's slightly more complex. But anyway, I think we'll make that mode available. But the first goal is to get the thing in the hands of users and see if the fundamental architecture and design is working right. And if it is, then we'll get to stuff like this next.
Cool.
Yeah, it is cool. I can tell you that. I am gotta say, I'm really impressed of what you've done and the quality hardware wise of this. And most of all, I'm no programmer, but I just downloaded the image and everything was up and running. I guess from start to finish, I used about 2 hours to get everything up and running and working.
Yeah, one thing that we learned when I first released it, I put out a document that said, okay, here's what you need to do to configure your Raspberry Pi. Download this thing, run this utility, edit this file, blah, 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 detailed instructions. No big deal. Anybody could follow it. And I would say just about most people in the beta group are pretty experienced, with Linux or with remote bases, blah, blah, blah. And every single person, including the people who are the most technically savvy, in my opinion, were like, man, I wish I just had an image. so I learned, so that was a real learning, usability is important. So at that point I thought, all right, I'll just configure the default, everything pre-configured. I'm going to save that as an ISO image. I'm going to publish that. And if you want to just, burn an SD card and plug and play, then go for it. And that's what I wound up doing.
Yeah, and that worked brilliantly. And we got to ask one question, George. Price-wise, where would this be?
Not
How
enough.
much? Because
It's one of the
I'm looking at
important questions. Yeah.
Yeah, I'm
Yeah.
looking at the quality hardware-wise of this, and I'm thinking this is not going to be cheap.
Yeah. Our slogan is, you can buy better, but you can't buy more expensive. So, so the way we are pricing this stuff, we sort of been through this with repeater controllers. We've been making repeater control systems for almost 20 years. And what we learned early on in the repeater controller business is that it's no fun selling cheap repeater controllers to people who want very few features, that it's more interesting making a full featured thing that's industrial quality. So the idea was to build a station controller that was as easy to use out of the box and as professionally built as we can make it, and with as much quality as we can bake into it. And of course, that's not cheap. So having said all that, the pricing, I think, is really not too bad. So in very round numbers, it's going to wind up being around $200 a module. And depending on what modules you need, you'd mix and match what you want. So for example, if you already have a Raspberry Pi and you don't want the host adapter, you don't need to buy the Raspberry Pi thing. You could just take a Raspberry Pi, or like I said, any computer, particularly a Linux computer. You could just install Node-RED and go. So you don't even need that. But if you want the convenience of the thing pre-assembled with an industrial strength built-in 12-volt power supply and all that stuff, this module with the Raspberry Pi, with the SD card, pre-imaged, out of the box, plug and play, will be about $200. Each of the modules will be about $200. So really the smallest configuration that's useful is going to be a host and a module. The biggest configuration that a normal station would have would probably be all 4 of the modules. So you're really looking at somewhere, if you're going to try to cobble it together with stuff you've already got, then it's just the price of the module. And you start with one, that's $200. If you just want to write a check for like a whole thing, it's going to be about $800. I'm not sure if we're going to do any kind of like bundled pricing. So there might be some sort of, you get all 4 modules and it's a little cheaper or something like that. But somewhere in that kind of price range.
And you're pretty spot on what I kind of made an assumption on what it would be, though. So I think the price is about right. That's what I kind of figured out when I saw it.
I think it's actually very reasonable. Let's say the one module that's easy to compare to something that exists already. That's the coax switch. And if you want a 4-port coax switch that you have to walk over to and turn, it's going to cost you that.
Oh yeah.
This one is infinitely more versatile than such a thing. So I think this is a perfectly reasonable pricing for this product.
If we were selling this into the industrial IoT world, the exact same thing, but like the GPIO module, this would be significantly more expensive. But part of the reason to do this is just because I like to do it, and it's for me, it's not so much to make a business, although that's true, but a lot of it is, I'm just interested in this, and it's an interesting problem to solve, and I love building things that other people use, and I get a lot of gratification out of that. So, we try to find a price point that seems reasonable, both from a business point of view and from a hobby kind of point of view.
But I think the price range is where it's supposed to be. From what I can see.
And on the other hand, people have to take into account all the cost of their other equipment, right?
Exactly.
If you have like 2 or 3 expensive radios, you don't want to use the world's flimsiest coax switch, right?
No.
In order to, blast your 100 watts from rig A into rig B or something like that. Yeah, you want some quality, yeah. And I think, that just costs a little bit.
I have one of these multiple antenna switches from a 3-letter maker that doesn't make products anymore. Let's put it that way.
Yeah, everybody knows who you're talking about.
And
starting with M, ending with J.
Yeah, pretty much. And that one,
I have the same one.
Yeah, I measured that, and that's all of the antennas to all of the radios at the same time, no matter which position the switches are in.
Yeah, indeed.
Well, I can promise that you won't hear a screw rattling around inside these. So that's the difference.
Okay.
That's fantastic. I have one comment and a question actually, as because you were saying you could use if you wanted to, you could use a normal PC. Couldn't you also actually, in fact, use both a normal PC and the controller?
Yes. Yeah. Actually, it's a really important point. So the architecture of the device control network, the DCN, there's a couple of aspects to that. One is the physical interconnection, and the physical interconnection over the Cat5 cable. Again, it's not Ethernet. The data connection is RS-485, and RS-485 is something that's been around for 40 years, and it's been used in industrial automation for those 40 years for these kinds of applications. And one of the advantages of RS-485 is it forms at the physical layer a multi-drop network, meaning you can hang multiple devices on that wire very easily. So just like in the normal configuration, you'd have one main controller, like the Raspberry Pi, talking to one or more modules. You can actually have one or more control devices talking to one or more modules all on the same network. Now, you have to give it some thought, like how many things are going to be simultaneously transmitting, and do you create collisions and stuff like that? So you have to think it through a little bit. But I'll give you my favorite example is on my station at home. When I sit at the computers and radios, one of the station accessories is a Stream Deck. So I have the 32 button Stream Deck. That Stream Deck plugs into my Shack PC. That Shack PC has a USB dongle that goes from USB to RS-485 that connects to my device control network. So I could pull up the web page and turn things on and off or switch antennas, or I could press a button on the Stream Deck and do the same thing. So when I'm switching antennas in the Shack, I actually use the buttons on the Stream Deck to control the antenna switch module to switch antennas.
I'm still waiting for the how-to on doing exactly that, George.
Yeah. So it turns out you can't do that out of the box with a Stream Deck. So Stream Deck doesn't have a serial control feature, weirdly enough. So I wrote a little utility, and I published it on the website, so you can download it. So the utility is a little program, and when you configure your Stream Deck, you use the launch function, the little rocket ship thing.
Yeah.
So that's normally used to just launch a program. So you use that to launch my macro program, and in the launch description on the Stream Deck button definition, you can give it some command line switches. So the program name -x-y-z, a whole string of options. What my program does is it takes those options and it then transmits serial data out to whatever you're controlling. So for example, if you wanted to change the relay, you press a button and it launches my macro program, and the parameters are at 9600 baud on port 10, send the following string, which is the command to select that relay. And so you press the button, it launches my utility, it squirts the command, and the program shuts off. It's that fast. It's actually faster. The neat thing about that is not only can you use that to control any of the station controller modules, but let's say you've got a radio with a serial port and you want to change modes or change bands or whatever, you can, instead of sending a serial command to my module, you can send a serial command to a radio. So I've got it working with ICOM radios and Yaesu radios to send individual commands or whole banks of commands. Like I got a button that says 40 CW, and it tells the radio, go to 40 meters, go to 7.040, change the mode to CW with one button press.
That is something I need to look into. I see my time is getting shorter and shorter in the coming weeks.
I think about right now.
And I'm actually, I've started, and I'm just going to put my overhead cam here. I've started on a button configuration, and this is how far I've actually come hardware-wise, because you have some ports on the coax switch where you short a couple of pins to switch as well. So I've started this, and perhaps it's gonna get finished at some time.
Seeing that, I'll be the resident Mark, because when I see this, I'm thinking, how trivial would it be? You'd need 4 buttons, any microcontroller, and the serial to 485 bridge, and you
Yes.
have a dedicated device for switching antennas. That
That's
would cost in parts. That would be less than $10.
Yep.
Yeah.
So you can make your own Stream Deck button board with 100%. That's exactly right. In fact, I was thinking about making that as a little product, but that's like number 10 on the list. So yeah, that's a great idea. And so by the way, to make that possible, one of the things that I'm doing is publishing the command structure. So and it's very simple. It's human readable ASCII text, and I explain the exact command syntax and how do you route a command to a particular device and what's the command syntax and all that stuff, and what is the data that comes back from the device to you. Now, if you have just a button board, maybe there's nowhere for that to go, or maybe you put an LCD display and it says. So, by the way, this is an important point we should really mention. When you execute a command like select antenna 1, for instance, what happens is whether it's a button board or the website sends the command to the relay module. The relay module decodes the command. Well, first of all, it says, is it for me? Yes. If it's for me, then decode the command. If it's a legit command, it executes the command. And if it executed a successful, legitimate command, then the module sends a packet back to the network that says, here's my current state. So what you get is when you press a button, like on the web page, you press the button, there's like a second pause, and then an LED on the web page changes from red to green or green to red or whatever. And the change in that LED is not because you press the button, it's because the device sent a message back to the Node-RED dashboard that says, here's the state of all the relays, and it updates those LEDs. So yeah, there you can see in the lower left.
Let's see. I'm just going to see if I can make StreamYard show stuff like I'd like it to.
If I could share the screen. Oh, there you go. Okay.
Yeah. I was just going to demonstrate while we talk here, though. But if I switch antennas here.
Nice.
So the reason for that, like 1 second delay, is because that's two messages. It's one message to the device, actuating the device, and then a message coming back to the dashboard.
So
and you probably want to code that when you have two of these coax switches, like many transceivers, too many antennas. You want to wait for both of these messages to arrive before you say go ahead and press your push to talk button.
Well, so let's say you're doing something like that, and let's say there's a collision, and something gets lost for whatever reason. That's the reason why you don't update the dashboard until you get the data from the device. So if there was a collision and data was lost, the dashboard would never change state, and you'd go, oh, that's pretty weird. I wonder why it didn't do that, and you'd just hit the button again, and then hopefully it'll clear it. But the device would have been in the right state because it probably, when it gets the command, it'll execute it.
Okay, one more question. What about this thing loses power and you connect again? Yes, we know we have latching relays, but does the board remember its last latching state, or does it go through some init sequence where it says, okay, let's make sure all the latching relays are actually in the state that I think they are in? How did you solve that?
So that's a good question. So this is when you make a project like this, getting something to work is easy. Getting something to work reliably in all possible conditions.
Oh, you are
is
telling
where all
me
the work
never
comes in.
underestimate the ingenuity of idiots in quotes, right? You can
no quotes needed.
Visual users. So what happens is, like, when you let's get the latching relay thing in a moment, but basically with any of these modules, when you set a condition, like turn on relay number 1, for instance, it turns on relay number 1. The module knows that relay 1 is on, and it writes the state of that relay into flash. If you unplug the power and plug it back in, now when you unplug the power on normal relays, they're all de-energized, so they go to their off state. When you plug the power in, one of the first things the board does is it reads the state of everything out of the flash and re-establishes the proper configuration before you lost power. So if you turn on relay 1, unplug the power, it goes off. When you plug in the power without doing anything, within a second, relay 1 comes back on because it knows it was on when the power went off.
And I can tell you that this works because
so you're basically refreshing the state, even though in theory the relay 2 should still be switched on?
No,
because
it depends on the relay. So these relays are not latching.
Okay.
So the relays and the open collector, well, obviously,
Sorry, I was thinking about the
Yep.
antenna one.
yeah.
Sorry.
But the antenna one does the same thing. So what the antenna thing is going to do is every time let's say you select position number 2, it also writes into flash that you had selected position number 2. When power is pulled, in this case with a latching relay, it's still connected to position 2. When power is reestablished, what'll happen is it'll say, what position do I think it's supposed to be in? And it'll reconnect into that position anyway, because
just for safety, because God knows what happened between power loss and
exactly
getting power back. You might have moved country in the meantime.
Exactly.
I'm just going to say that on the GPIO board, I know for a fact that the relay, when you reboot it, remembers the last position, because my Flex has done a lot of on and off switching, which was not supposed to do. Let's put it that way. When I've been experimenting and pulling power and putting power back on, and I see the light on my Flex starts flashing, so it does work.
But you're saying you write this to flash? Is there no EEPROM on the
well,
module?
No. So this is one of the things that was one of the challenges. So if you're used to AVRs, there's flash. There's two kinds of memory in an AVR, typical microcontroller. Same with a PIC. You've got program flash and you've got data flash. And with the ESP32, the raw processor chip itself has no data flash. So they have an external flash chip, and they don't support an EEPROM natively. And in fact, when you go to use the ESP32, the new family of parts, they say they don't support even the commands of EEPROM anymore. Now it turns out they do, but the way they do it is that they make an image of. So if you define a bunch of EEPROM memory locations in your code, it will create a table in RAM. And if you write to that EEPROM thing in the AVR, it writes to the flash. In the ESP32, it writes to the RAM. Now, if you lose power, you're kind of up a creek. So what you have to do is every time you write to the EEPROM in the ESP, after the write, you have to add another command, which is called commit. What commit does is it takes the whole table of data and writes it to flash.
This is part of the SDK from Expressive, is it?
Yeah, it's just the way because the way they designed their hardware, they had to implement that. So first of all, the number of write cycles. So this is an important factor. The number of write cycles is like 100,000. So you're not going to want to do this a lot. So you have to be careful about how often you actually write to the flash. So something like store the value of my relay, no problem. But you don't want to be storing the flash data like every second, because eventually you're going to burn out the flash. So
yeah, I mean,
so
there's an. Sorry to interrupt. Somebody is interested. There was a talk recently on the Chaos Computer Club about a guy who resurrected an old satellite. Yeah. So if you want to read about Flash getting corrupted, learn about that. I recommend to listen to that. And these flash memories are usually also organized in sectors. So you have different sectors which are like, I don't know, depending on the flash, can be blocks of 1 kilobyte, 4 kilobyte, 8 kilobyte, whatever. And then it would make sense to put all your data in one specific sector and basically say, this is my configuration variables. Yeah, you don't want them scattered around with the rest of your firmware, and by accidentally losing power at the wrong second, basically losing your firmware.
So there's two other things that we can do to solve that. One is the recommended methodology for an ESP is to use a function called preferences. And preferences is much more powerful than EEPROM because you can actually create a whole file system in the flash to store images, data, whatever. So it's much more powerful than EEPROM, but it's also more complicated. So that's a learning curve. But the other thing that we did was on the newest version of the GPIO module, for example, we also added an EEPROM chip. So right now we're not actually using it, but it's there just in case, because they're inexpensive, so why not? So it's an I2C EEPROM chip. So currently all of the configuration data is stored in the ESP's flash, but we may wind up using the outboard flash for configuration data.
Well, I think if it's rated for 100,000 writes, then I think that's more than the EEPROMs in some of the old
Actually,
picks in,
the common EEPROMs you see, like 24LC 512s and stuff like that, they're rated for 1 million writes.
Oh.
And actually, the lowest thing I've seen is the flash and the ESP, which is kind of surprising, actually, that it's so low. I mean, for these applications, it's fine, as long as you are careful about what you actually commit, how frequently you commit data to the flash.
Yeah. Nice.
Nice.
I actually had one more. We're running really into overtime. I need to get this question in. I have projects. I come up with about 25 new projects every day, and I start looking into them. And yeah, but the relays on that board. How do you know what relays are rated for and good for RF? Because I went looking on RS components, which is what I normally use for relays for RF. It wasn't apparent to me how to identify the ones that will be good for RF.
Yeah, so here's kind of the rule of thumb. It's all frequency dependent. So if you're talking about switching HF frequencies, maybe up to 6 meters, then any non-RF DC AC power control relay is going to be fine. So if you look inside any HF radio that's got a TR relay, it's not an RF relay that's in there. So what you really want is you want a high quality relay from a reliable vendor, blah blah blah. But it's not an RF relay per se. But you can get away with that because the amount of wiring through the relay and on the circuit board is such a small fraction of a wavelength that it's insignificant.
Doesn't matter on HF. That's what it's telling me. Yeah, you have
but let's
problems
pop up
when you go SHF.
Well, for sure. So let's even go to UHF. Okay, at UHF, so from a pin to pin on a relay, you may wind up going through like an inch of copper. Hopefully it's copper. Plus there's some traces. So you may have like 1 to 3 inches of wiring in that relay circuit, and a quarter wavelength is 6 inches. So it's like this is a significant portion of a wavelength, which is one reason why you can't really use those relays at UHF. So the way you solve that is you go to an impedance controlled RF relay. Now, I've also built switches. In fact, one of the things I'll probably come out with is I already have the design done. It's a 2-port VHF relay, which would work acceptable at UHF too, by the way, but it's really meant to be really good at 2 meters. And it uses a 50 ohm impedance controlled relay because it's designed for that. The problem with that is that the part cost, not to build a controller, the part cost for that relay is about $50.
Yeah.
So
I guess so.
That's the reason you don't build an HF relay switch box out of that, because to do what I have here, I would need 4 of them. So my bill of materials cost would be $200 just in relays, let alone everything else in the assembly. Yeah. So if my cost is $300,
there's a gold ribbon as the enthusiast edition.
Yeah. Now, having said that, if you're a VHF UHF operator and you need a 2-port coaxial relay, you're going to expect to pay $200-300 or whatever for that, and then that's probably enough to pay for it because it's got 1 relay in it. So okay, fine. So that's why I don't do that for HF. So at HF, you have the luxury of using cheaper parts.
All right. One of the things that's in my head about this, if you create a Yagi with a horizontal set and a vertical set, you can put relays preferably up on the mast, and you can switch that between horizontal, vertical, right hand polarized and left hand polarized. And I'm not sure, but I think I'd need at least 4 relays for that. So if I want to do that for UHF, that's probably going to be expensive in relays.
I think you could do that with 2 relays because you're really because the driven element, one side typically, it depends on how you're feeding it, but typically one side of the driven element is it ground or not? It kind of depends on how you're matching it. So you're really switching the feed point on one side of the driven element. So that's 2 relays. But it depends on your feed point.
Yeah. There's also the delay line. When you do the circular polarization, you need a delay line that's going to be switched in and out. But maybe I could just stay there permanently. It shouldn't matter, or for as long as you're doing just the one polarization, it doesn't really matter that it's there all the time.
Well, one tip also is you don't have to use connectors. So when I've seen some of those kind of relays for that kind of purpose, for polarization switching, a lot of times you'll just run the coax right to the circuit board and just forget the connector, one little more failure point. So that's another way to reduce the cost too.
Yeah. Sorry, that was a really big tangent. But when I have you here and the ability to ask questions, I'm not going to miss out.
We are on serious overtime, as you said, Bob. We were kind of expecting it, though. But thank you so much, George. And again, I feel like we've just barely scratched the surface. So I'd recommend people to check out the Ham Radio Workbench podcast. And there is an episode where you talk about the station controller, and people can learn a lot from there. I think that's a good tip for people that want to learn more. And then there's always our Discord and the Ham Radio Workbench Discord. And I guess people can get their questions answered there as well, George.
Yeah, for sure. Yeah, the Ham Radio Workbench, there's a channel just for the station controller, and people hang around there and ask questions. We also have a groups.io page, which right now is private, so it's only for the people in the beta. And all the documentation and software links and the chit chat on the message boards are on that groups.io page. And as soon as the product is ready for shipment, general sale, probably February, I'll turn that into an open forum.
Okay,
Nice.
do we have a website, where people can
Yes.
get their pre-orders in, or
Well,
maybe you?
that's a great question. Thank you for the question. So there is a website. There's no way to do an order, though. The company is Sierra Radio Systems, and the website is sierraradio.net. And you can see info
I'll
there.
put it up on screen here so people can see it. There we go.
Yeah.
So you can see some of the things that we've made. So the current thing is the station controller we've been talking about at the top. Below that is our repeater control systems, and then we talked about the Adventure Radio Protocol controller. That's it down at the bottom, which is there's a few of those out in the wild. And after the station controller hubbub dies down a bit, I'll get back to the Adventure Radio controller.
I'm guessing that this both has taken a lot of your time and is going to take a lot of your time once this goes live.
Yeah, definitely. So there, you click on there, you can see more info. So this gives you the top level specifications. By the way, on the picture there, you see the little board in the middle. That's an optional hub. You don't need that. The Raspberry Pi host adapter has a hub built in, so you can connect up to 3 devices. So for this example, we didn't need the hub. We could have just clicked them all into the Raspberry Pi. But you can see the hub, which also has a power pole jack, a barrel jack, 5 DCN jacks. So you can extend the network to as many devices as you want.
Yeah.
Do we have 30 seconds for one last point?
Yeah,
Before we pull the plug?
Absolutely.
So one thing that we did not talk about is the ability to extend the network wirelessly. So you think about installing this at your remote station. You've got those boards, you hook them all up, and there you go. But there's times when you want to put one of those modules far away from the shack. So let's say, for example, like my buddy Mike at his remote station, he wants to put a couple of the coax relays at the tower, and the tower is a couple hundred feet from the shack. So, for example, you can have multiple antennas going to the relay board and then one coax line coming back to the shack. So, okay, well, how do you control the coax relay module? And there's 2 ways to do it. One way to do it is you run a piece of Cat5 cable, 200 feet, and the Cat5 cable will supply both power and data. So that'll work fine. The other thing you could do if you have power out there is you could replace the cable with a data radio. And so we've been using different data radios to test with. So this is an example of one. This is a 900 megahertz data radio. They also make them for 868, so you can use them in Europe. And this thing has a RS-485 jack on the side. So you literally take 2 wires from one of the connectors, one of the terminal blocks on any of the modules, take 2 wires and plug it into this thing, put 12 volts on it, and it's now transmitting the DCN data back and forth at 900 or 868 megahertz. And these come in 100 milliwatt and 1 watt versions. So it's a way to very easily extend the network, and it works really, really well.
And then you
Great.
can use Meshtastic as well, George.
Well,
can't you?
funny you should mention it. So one thing I didn't mention was there's these headers here. Those headers will let you plug in a Meshtastic Heltec V3 module right there on the board. And let's say at the other end, I didn't show you this either. There's a Heltec V3 daughter card, so you could put a remote module. So you can provide power in here to run the Heltec module, and then you put a little antenna there, and your DCN connector is here. So you can, for example, take a GPIO module and the Heltec radio board, piece of Cat5 between them, and now you've got a remote GPIO module running over Meshtastic. Having said that, I can tell you while it works, Meshtastic injects a lot of latency. So I would only use it for very specific applications where fast turnaround is not required. If you really want real-time turnaround, you really want to use these kind of data radios. But anyway, it's an interesting option. So it really speaks to kind of the universality of the way the DCN architecture is created.
And I just got to say once again, I love this product, George. It's solved so many of my issues that started popping up when I bought the Flex and thought, I'm going to do remote now. And once I got the radio, I figured out there's a lot of other things I need to control.
Yeah.
And,
so we actually use it. We have an electric fence around part of our property to keep the deer from eating our garden. And so the problem with an electric fence is that it's a 20-meter noise generator. And so I have a module sitting down on the electric fence that I remotely control from the shack. So, you do think of all kinds of other applications.
You can solve your very specific local problems with this.
Yeah. But that really speaks to the versatility of this solution. You can solve a lot of problems that you didn't even think you were going to have with a solution like this. So excellent work. This I'm going to look forward to hearing about this a lot in the future.
And I kind of remember you talking about that Meshtastic is a solution looking for a problem. I'm guessing you found your problem now.
I did. I did actually. But the funnest thing about it. Do you have time for one more little side?
Yeah, we do.
Yeah,
we're so overtime that
this will be 2 episodes. So one thing that occurred to me when I was building this, when I did the Meshtastic module, you type on the Meshtastic messaging app the command, but you have to type exactly the right set of characters, which is not difficult. But it's like 10 things. You got to type exactly the right things to get the relay to flip. And then it flips the relay and it sends back the update. And you could read the update string and see that the thing flipped. But anyway, that's fine. Then it occurred to me, wait a minute, I can just hit the microphone button on my iPhone and I could speak into it and it'll convert it to text. So I could say controller relay 1 on, and it creates that set of words, right? And it transmits that set of words over LoRa. Or rather over Meshtastic. On the other end, those words pop out into the controller board. And so I modified the firmware to parse English words. And as a test, and if it says turn relay 1 on, and it turns relay 1 on. And so I could literally voice control the thing with like almost no effort, because like I didn't invent anything. I just used I just added in the firmware. I just added English language words to the parser. And when
is multi-language support coming for this?
That Norwegian stuff is more complex. I'm going to start with Finnish because that's easy.
Yeah, the swear word parser is something you should think about. For emergency shutdown of the rig or something.
Yeah. But I just realized I need to play a lot more with this because the possibilities are endless and the time is limited. That's what I'm seeing now. Thank you so much, George, for being on. We'll be on next week. I have no idea what we're going to talk about because I haven't looked at our schedule for a while. It's going to be something exciting. If you want to see more of George or hear more of George, check out the Ham Radio Workbench. Thank you all for watching. Thank you to all the new members. We'll see you next week. 7-3 all.
73,
folks. Bye.
Thanks.